this video talks about the distance formula, and you might remember the distance formula from other math classes, geometry, algebra 2, and then even algebra 1. So this is the distance formula. I have it written down here for you. But I talked to you guys yesterday about not really memorizing formulas, really looking at the formula, figuring out what it means, and instead of getting hung up on these labeling of x's and y's, if we could just master how to do the formula, we won't need to actually memorize the formula. So I'm going to draw a little coordinate plane here. I'm going to plot some points. Okay, and I'm going to find the distance between these 2 points. Now, if these were vertical or horizontal, you could easily count what the distance is, but you can't really count the distance going diagonally, but we can count distances that are vertical and horizontal. So if I were to make vertical and horizontal distances, you would notice that I make a triangle, and the kind of triangle I just made is a right triangle. You could figure out that this is 1, 2, 3 units long, and this is 1, 2, 3, 4 units long. And if you remember, when you're solving for a right triangle, you can use the Pythagorean formula and do 3 squared plus 4 squared equals c squared. So you'd get 9 plus 16. This would equal 25. That's c squared, so your value of c is 5. Okay? Now, all you did when you got 3 and 4 is you essentially, behind the scenes, kind of calculated the distance from here to here first. So this was at 2, 2, and this was at 5, 2. So without actually doing it, you already calculated the distance from 5, 2 to 2, 2 by subtracting 2 and 5 in your head and got 3, okay? Or you just did it by counting. Same thing over here. You really counted these spaces, but they were 4 away from each other. So now you look at the distance formula and you say, or I say, let's try to figure out where this distance formula came from. So if I look at these 2 points, remember this was at 2, 2, and this point that's up here is going to be at 2, 3, 4, 5, 6. So if I were to take these and substitute them into the distance formula, which essentially is where the Pythagorean theorem came from, I would say this is the square root of x2 is 5, x sub 1 is 2, squared plus y sub 2 is 6, minus y sub 2 is 2, squared. And if I do this, I get 3 squared plus 4 squared. But remember up here, I visually calculated the distance and got 3 here and 4 here. So this 3 and 4 is the same thing as this 3 and 4. And the square root is what you had to do at the very end. So if I were to make this the problem at the beginning, at the very end, you would just take the square root and get 5. So the distance formula and the Pythagorean theorem are literally going with each other hand in hand. So if I want to use the distance formula, I can substitute it in, and I can do it this way. Okay? However, my job is to have you guys master what is going on here. So instead of memorizing this formula, let's just talk about how to master the formula. The length of line segment A. Okay, well here's A. I already wrote the points for you. A is located at 6, negative 4, and negative 2, 7. Remember, yesterday I had you line up your points so that you had X's and Y's on top of each other. And yesterday when we found the midpoint, we added these together. But the distance formula says that first you have to figure out what is the distance between X's and what is the distance between Y's. So I'm going to do the same thing today. I'm going to take 6, 4, 6, negative 4, and I'm going to take -2, +7. Actually, I'm going to move this down here. Cross out letter C, we don't need to do all of these. Okay, and I'm going to first find out what is the distance between my x's and my y's. So in order to find the distance, I have to figure out what is the difference. 6 minus -2 is 8. -4 minus 7 more is -11. So the 8 and the -11 are what the 3 and the 4 were in this picture. Then it says I have to take my differences and I have to square them. And once I square my differences, I can add them together and then use the square root as the last step. So instead of doing this entire thing as the distance formula, I'm sort of condensing it here and just saying it to myself in my head. Find the distance, square them, add them, take the square root. It's the same thing as the Pythagorean formula. So this becomes 64 plus 121, which becomes 185. And remember, the way we're going to solve these is if we can take out a perfect square. We're going to go ahead and simplify the radical. We're not going to get a decimal. I don't think we're going to be able to get any perfect squares that go into 185, so we're just going to keep it as root 185. I'm going to go ahead and scroll down here. Find the distance between these 2 points, 4, 8, and 2, 2. I think that's -4. -4, 8, and 2, 2. Okay, I'm finding the distance. So I need to first find the difference. -4 minus 2 is -6. 8 minus 2 is 6. Then I'm going to square them, add them, take the square root. This becomes the square root of 36 plus 36, which is root 72, which you can then factor out root 36 and root 2, which makes sense. 2 roots of 36. Okay, well, here's 2 36s in a square root. So you could have just went right from here. If not, this becomes 6 roots of 2. Go ahead and try this one. So you should get 2 root 65. The next one, you don't have a graph here, but you can sketch one real quick. It wants to know what is the length of the diagonal of a square where the vertices are at 0, 0, 4, 0, 4, 4. And so obviously if this is a square, your other vertex would have to be here at 0, 4. They just want to know what is the length of the diagonal of the square. Really, you don't even need to use the distance formula here. All the sides of the square are going to be 4. And so if you look at this right triangle, you have 4 squared plus 4 squared equals c squared. This is 16 plus 16. At this point, you're just using Pythagorean theorem. So this winds up being 4 roots of 2. The other way you could have done that is because it's a square and you're cutting the square in half. Remember the 45, 45, 90 right triangle? So if this is 4 and this is 4, then very simply the hypotenuse is 4 root 2. Okay, this one's just practice problem. Okay, this question is talking about a plane, and it says the point of no return in aviation is the farthest point to which a plane can fly and still have enough fuel to return to its starting place. So this is telling you that the plane is flying from airport A to airport B. Each one of these little tick marks on the grid is 50 nautical miles, so it's 50 miles in the air. Right now, the plane is at the midpoint of the flight. How far away is the plane from airport A? So if we first figure out what the distance is between 1,1 and 4,7, right now the plane is about root 45. Now, since this is a real world question, we are going to get the square root. And approximate it to be about 6.7. So right now, the planes are about 6.7 units away on the grid. Remember, each of these is 50 though, so we're going to multiply this by 50. So right now the planes are about 335, I'm sorry, the airports are about 335.4 miles away from each other. Remember, this plane is at the midpoint, so if you divide this by 2, you'll see that the plane is about 167.7 miles away from the airport. The plane's point of no return is calculated to be 200 nautical miles. Has the plane reached its point of no return? And then explain. So at this point, it has not reached the point of no return. The point of no return for this plane is at 200 miles. So around here would be 200 miles because the whole trip has to be 335. So if the plane needed to turn around right now, it could. But once this plane goes past 200, it can no longer turn around. So either something would happen to the plane in the middle of the sky, or it would have to just try to make it to the other airport. Once it goes past this point, it cannot return back to where it came from. So as of right now, no. I can't even read this, so just lucky us. Skip. Last one. This is a good quiz question. Okay, it says you have 2 points, X and Y. I'm sorry, A and B. And the points for A and B as expressions are given by W and W plus 5 and 4W and W minus 5. So I want to find the distance between these 2 points. So I'm going to line them up and subtract them. This is where things get a little bit tricky. I want you to think about what you're actually doing here. You're saying W minus 4W. That one's easy. It's negative 3W. Then you're taking W plus 5, and you're subtracting W minus 5. See how you're taking away the entire quantity, which means that you're really going to have to distribute the negative, minus W, and then plus 5. Which means that, lucky for us, these W's eliminate each other, and then 5 plus 5 is 10. Then you're going to square, add, and then take the square root. This becomes, remember, you're squaring this entire thing, so you get the square root of 9W squared plus 100. So you get B. You cannot separate these. Do not do anything with a square root. Just leave them how they are.